Good evening, friends. In the previous video, I have talked about power plant sector across the globe, how the power plant influences the global economy, and how the energy utilization dependency influences per capita income. The world countries' economy is decided by power utilization and power generation. And I also gave some major classifications of resources, and I gave overall idea about power plant in Tamil Nadu as well as across the country. Now in this video we are going to talk about coal based power plant, that is a thermal power plant. In Tamil Nadu nearly 7,500 megawatt of power is being generated from burning the coal, that is thermal power plant or coal based power plant. It has advantages as well as disadvantages. Advantage in the sense we have a resource for another 50 years, it will last for another 50 years. At the same time, we are importing coal from Australia and other countries. The disadvantage is pollution coming out from burning the coal. Lot of pollution, fly ash, and in and around the power plants for 10 square kilometers. The air pollution is very huge. Particulate matter pollution is also very high. It crosses the standard fixed by Bharat Stage 6. Air pollution is maximum around that coal-based power plants for 10 to 15 square kilometer. Further, to minimize the pollution, many technological evolutions are taking place, and those things also we are going to discuss in the coming videos. In this video, we will be discussing about the major areas covering the cycle, that is vapor power cycle called Rankine cycle, and layout of modern coal-based power plant, supercritical boilers, fluidized bed compression, turbines, condenser, steam and heat rate, fuel and ash handling, DOT system, feed water treatment, binary cycle and cogeneration system. So if you talk about Rankine cycle, with straight away you could not go to the Rankine cycle, we have to touch upon Carnot cycle, which was the basic cycle. Even though it is not practically possible or we could not implement the Carnot cycle, but we are taking the concept and other thermodynamic related processes for deriving Rankine cycle. Rankine cycle is also called as vapor power cycle. This Rankine cycle is not only meant for coal-based power plant, it is also applicable in nuclear power plants. Wherever we have steam expansion in the turbine, we have Rankine cycle. Here I have given the fundamental basic Rankine cycle. You look at this cycle, Carnot versus Rankine cycle. The temperature entropy cycle, here we are seeing that vapor dome, this is called the vapor dome. How the heat is added and how the steam expands in the turbine by following constant entropy, that is isentropic process. After expansion, steam enters the condenser where heat is removed and vapor is converted into hot liquid, that is the heat rejection process at constant pressure this is taking place. This hot liquid is pumped to the boiler by means of pump. The pump works on isentropic process, keeping entropy constant. and raise the pressure to the boiler pressure. At boiler pressure, it enters the boiler, and there the heat is added by means of burning the coal. So this is called Rankine cycle. This is a basic fundamental working of Rankine cycle. Okay, in the power plant, we are achieving 30 to 35% of efficiency, but it is far less compared to foreign countries. In foreign countries also they are using the same principle of Rankine cycle. Still, they are ahead in terms of efficiency by 2-3%. There they are getting around 40% efficiency power plant. Here we are getting 35 to 38% of efficiency. What are the ways and methods to improve the Rankine cycle or power plant efficiency? Across the globe, they have identified by implementing three principal changes, we can improve the efficiency of Rankine cycle. First one is decreasing the condenser pressure. Normally it is in the range of 0.01 bar. Still they want to increase the condenser pressure. That is, they want heat rejection to take place at constant pressure, still at lower pressure. That is the one way of increasing efficiency. Second, increasing the boiler pressure. We know that the boiling point and pressure are proportional. If we increase the boiling pressure, the boiling temperature will increase. For example, at 1 bar pressure, the water will boil at 100 degrees Celsius. Whereas at increased pressure, 10 bar, the boiling point of water rises to nearly 175 degrees Celsius bar. Let me repeat. At 1 bar, boiling temperature of water is 100 degrees Celsius. At 10 bar, boiling point of water is 170 bar. This is the principle behind our pressure cooker, rice cooker, what we are using at our homes. So if we increase the pressure, the boiling temperature will increase. So we have to increase the boiling pressure. Third is superheating the steam to the higher temperature. So if the temperature of the vapor increases, the energy content will also increase. That is, enthalpy will also increase. If we expand the high level of enthalpy, that is high energy, the turbine will be getting more power output in the turbine shaft. That is the reason behind increasing the superheating the steam to a higher temperature. These are the three methods to improve Rankine cycle efficiency, thereby improving overall plant efficiency. Okay. So if you look at this temperature entropy diagram, very clearly I have given how the decreasing the condenser pressure influences increasing Rankine cycle efficiency. See 1-4-4-1-. 4-1- is the decreased condenser pressure, thereby area we are increasing. The area, that means in the temperature entropy diagram, heat, it denotes the heat. If you look at this boiler pressure, here also we are increasing that area, that is, look at this 2-3-, the pressure has been increased. And if you increase the temperature 3 to 3-, so thereby we are increasing the area and efficiency of the plant. Everything will have some side effect. Here also it has some side effect. The condenser, there may be some problem will occur due to the below saturation pressure. If you increase the boiler pressure, the moisture content of the inlet vapor to the turbine increases and corrosion may take place. If you increase the temperature beyond the limit, it will destroy the turbine blades. For that we have to do some technological advancement. Likewise, increasing the blade material, that is quality of the blade material should be increased, and other areas we have to concentrate. So thereby we can increase the efficiency at the same time with less expensive. Okay. So with this I stop this video. In the next video we will be discussing about fluidized bed compression and their advantages and disadvantages. Thank you.